Hi, everyone. Thanks for tuning in to another Silicon Labs podcast. Joining me today, I have Linda Lua, who is our PCI Express product manager. Go ahead and say hello, Linda.
Hi, Isaac. Hi, everyone. Isaac, thanks for the introduction. I'm looking forward to discussing or chatting with you on PCI Express.
Yeah, I have a few questions for you. First off, what is PCI Express?
Yeah, very good question. So PCI Express is the abbreviation for Peripheral Component Interconnect Express. PCI Express, or commonly known as PCIe for short, is a high-speed serial point-to-point interconnect standard developed and maintained by PCI Special Interest Group, which is also known as PCI SIG. The serial interface sends both data and clock using the same wire, allowing for high yet scalability in transmission rates, reduced complexity and cost compared to the older parallel transmission architecture.
I see. I've heard of the group called PCI SIG. Does Silicon Labs participate with this group, and what do they do?
Yeah, absolutely. So Silicon Labs is a member of PCI SIG, and we participate in all our meetings. So we're always updated with their latest specs. So normally in the PCI SIG meeting, the members will get together. They will discuss about the next generation of the PCI Express specifications.
Okay, for this particular bus, what sort of applications use PCIe, and how long has this standard actually existed?
Okay. In a computing system, PCIe is used for connecting peripheral devices for data transfer. So peripherals include graphic cards, network interface cards, storage accelerator devices, solid-state drives, the SSDs, hard drives, Wi-Fi, and other high-speed peripherals. And because PCIe implementation is very simple, low cost, and it's standardized, we're seeing the PCI Express bus being used outside computing systems, and we've been seeing it in applications like in cameras between the image sensor and processor, Thunderbolt for battery charging, and also video applications. So the older parallel transmission bus, which is the predecessor to the PCI Express, they're known as PCI or PCIe, and they have been in existence about 20 years now. And the PCI Express Gen 1 was released in 2002, and right now we're in 2018, and we're in PCIe Generation 4.
Wow, 20 years. So with each gen of PCIe, the data throughput of this bus, I guess, is increasing. How have the timing requirements changed with each generation?
Right. It's been changing quite a bit. And even though the clock frequency for PCIe remain unchanged at 100 megahertz, plus minus 300 ppm, the timing requirements have changed quite significantly from Gen 1 to Gen 4. Most notably from Gen 3 to Gen 4.
What exactly is driving these requirements? Is it mostly tighter jitter requirements, or can you expand on that?
You're right. So definitely tighter jitter requirements. So from Gen 1 to Gen 3, the data rate for PCIe has increased from 2.5 gigabits per second to 16 gigabits per second. So higher data rates require more accurate clock. And in Gen 4, other than the common clock architecture where same reference clock source is used at each end of the PCIe link, there is an introduction of separate reference clock architecture where a different clock source is used at each end of the PCIe link. So when different clock sources are used, less jitter in the reference clock will ensure no broken communication between both the PCIe endpoints that they're communicating with each other.
So we definitely have a wide timing portfolio at Silicon Labs. Would you be able to give an overview on which of our latest timing parts are PCIe compatible?
Oh, yeah, absolutely. So last year, around November 2017, we introduced one of our clock generators, which is an any frequency, any output clock generator, the SI5332. So the SI5332 supports 6, 8, and 12 outputs, is any frequencies up to 333 megahertz. And with this clock, it not only supports PCIe up to Gen 4, it can also provide reference clock for other end devices like FPGAs, switches, PHYs. And the jitter performance is really good on this device. The RMS phase jitter typical is about 230 femtoseconds. The output format for this device is programmable. HCSL, LVDS, LVPECL, LVCMOS, so it's a very, very flexible part. And in terms of SerDes, it can meet up to 28 gig SerDes. And it also have built-in spread spectrum profile, so you don't need to configure it to calculate the percentage. So we already have built-in, they can be I2C control to turn on and off, and also hardware pin control. Other than any frequency clock generator, we also have a family of PCI specific clock generators, which is the 52200 family. So 52200 family PCIe clock generator supports 2 outputs, 4, 8, and 12 outputs. And it only needs a standard external crystal, 25 megahertz, and the output frequency, of course, is 100 megahertz, but you also have options for 133 megahertz and 200 megahertz. Jitter performance for Gen 4 typical is 241 femtoseconds, and so you have a lot of jitter margin because the Gen 4 limit standard is 0.5 picosecond. The 52200 family supports 1.5, 1.8 volts part. They're in very small packages, so even for applications where it's space constrained, that's a very good part to use, and low power. Besides our PCI specific clock generators, we also have another family which is a PCIe specific clock buffers. So fan-out buffers and also zero delay buffers. Let me talk about the fan-out buffers first. The fan-out buffers which supports Gen 1 to Gen 4 is the SI53200 family. In this family, it supports 4 outputs, 8 outputs, and 12 outputs. So for the 53200 buffer family, it is a fan-out buffer with no zero delay functions in it. Voltage supply is 1.5 volt and 1.8 volts. If your customer is looking for 2.5 volts or 3.3 volt part, we also have another family which is fan-out buffers, PCI specific. It's the SI531X family. So that supports up to 9 outputs. And other than that, we also have a family of zero delay buffer, which is compliant to Intel white cover specs, compliant to Intel's DB1200, DB1500, and DB1900. So as you can see, we have a very comprehensive portfolio to support any PCI applications in different market segments.
Great. Thank you for giving that thorough overview. I'd love to continue this conversation and learn a little bit more about our product offerings, but that's all the time we have today. Thanks for joining me, Linda, and I look forward to continuing this conversation with you.
Thank you. Thank you, Isaac. Thanks, everyone, for listening.